There's a secret to modern life. A few, actually. Secrets that have been working hard for you for decades. Look closely and you will find them everywhere. They're in your walls, in greenhouses, on the trains and inside your wheels. They're in the ground. They're blocking sound, insulating, irrigating, purifying, fortifying, so you can focus and play and live and be happier. Getting on with what's most important to you without your surroundings getting in the way. And helping businesses thrive more efficiently while respecting the environment. For the last 80 years, we have been unlocking these secrets inside stone. And we found that by applying our curiosity, passion and knowledge, we could recreate stone's natural cycle and optimize the use of resources by converting waste into valuable material. Today, stone wool improves people's work and well-being in all kinds of different ways. It plays a big part in making people's life richer, more productive and more beautiful wherever they might be. But we're sure there's more, and we are absolutely determined to find it, so we can do even more to improve life in societies around the world for decades to come. You might never see these secrets hidden around modern life, and you don't have to. We are proud that you experience their effects every day. There's a secret to modern life. A few, actually. Secrets that have been working hard for you for decades. Look closely and you will find them everywhere. They're in your walls, in greenhouses, on the trains and inside your wheels. They're in the ground. They're blocking sound, insulating, irrigating, purifying, fortifying, so you can focus and play and live and be happier. Getting on with what's most important to you without your surroundings getting in the way. And helping businesses thrive more efficiently while respecting the environment. For the last 80 years, we have been unlocking these secrets inside stone. And we found that by applying our curiosity, passion and knowledge, we could recreate stone's natural cycle and optimize the use of resources by converting waste into valuable material. Today, Stonewall improves people's work and well-being in all kinds of different ways. It plays a big part in making people's life richer, more productive and more beautiful wherever they might be. But we're sure there's more, and we are absolutely determined to find it, so we can do even more to improve life in societies around the world for decades to come. You might never see these secrets hidden around modern life, and you don't have to. We are proud that you experience their effects every day.
Bye-bye.
There's a secret to modern life. A few, actually. Secrets that have been working hard for you for decades. Look closely and you will find them everywhere. They're in your walls, in greenhouses, on the trains and inside your wheels. Then the ground. They're blocking sound, insulating, irrigating, purifying, fortifying, so you can focus and play and live and be happier. Getting on with what's most important to you without your surroundings getting in the way. And helping businesses thrive more efficiently while respecting the environment. For the last 80 years, we have been unlocking these secrets inside stone. And we found that by applying our curiosity, passion, and knowledge, we could recreate stone's natural cycle and optimize the use of resources by converting waste into valuable material. Today, Stonewall improves people's work and well-being in all kinds of different ways. It plays a big part in making people's life richer, more productive and more beautiful wherever they might be. But we're sure there's more, and we are absolutely determined to find it, so we can do even more to improve life in societies around the world for decades to come. You might never see these secrets hidden around modern life, and you don't have to. We are proud that you experience their effects every day.
Good afternoon, everyone. Really good afternoon to all of you. It's so nice to see all of you here. A really warm welcome to all of you for today's webinar. Thank you so much for joining us today. We're really excited to have you for the 5th webinar of Glasstech Asia times PERAFI's series of webinars. If this is your first time with us, let me introduce to you what this series of webinars are all about. Glasstech Asia is delighted to collaborate with PERAFI, Indonesian Façade Association, to produce this series of webinars to focus on facades and its related building materials. And the objective is to improve the quality of the building facade industry through active discussions on key topics and content sharing from different international industry experts. These webinars are supported by BAO and BAO China, which are part of the BAO network organized by MMI Asia and Messi München. Before we move into the webinar proper, allow me to first introduce Glasstech Asia and PERAFI. So Glasstech Asia, held together with Fenestrasian Asia, are annual exhibitions that focus on all things glass and are also known as the Glass Hub of Southeast Asia. Glasstech Asia is the leading BAO trade fair, while Fenestrasian Asia exhibits numerous products, services, and innovations from the window and door industries, as well as facade technologies. PERAFI, Indonesia Façade Association, is an independent organization which seeks to grow the building facade industry by establishing sustainable business relationships and ensuring clear regulations and standards. PERAFI also advocates for the improvement of technology, materials, and methods to achieve good quality facade, especially in Indonesia. So good afternoon to all once again. My name is Sarah Ang. I am the Director of Scenographic Design in Singapore, and I will be your MC and moderator today. Today, we have an exciting lineup of speakers, and we'll be focusing on something a little bit out of the ordinary, the topic of facade beyond glass and metal. You know, other than your typical glass and metal facade, what are some other materials or upcoming technologies applicable for building exteriors that we can look forward to? On our wonderful panel of speakers today, we have Mr. Jay Fong from LWC Alliance, Ms. Sandrine Guibert from Novacell, Mr. Rafael Pasaribu from Abode Design, and Ms. Azani Asmi from Rockwool Asia. After each presentation, we will be taking one quick question. So please send in your questions anytime during the presentation, and you can do this by typing in the chat box. After the presentations, we will be having an interactive discussion round, and we would like to invite all of you to raise questions and share your views on the topic. Please note that we'll be switching off your video and microphones. Before we start very soon, we would like to give a word of thanks to our sponsors first, very important, Novacell as well as Rockwool Asia. Novacell is a company that designs, manufactures, and sells self-adhesive films, high-performance laminators, technical tapes, and performance coatings for surface protection for industrial sectors such as building, household appliances, automotive, electronics. Novacell Protective Film provides an extremely effective protective barrier against external damages and can be applied to materials as varied as metals, to plastics, to textiles, and glass. As for Rockwool Asia, the Rockwool Group is a multinational group of companies from Denmark that focuses on developing and manufacturing solutions from stone wool to address needs in the construction, industrial processing and manufacturing, infrastructure, marine and offshore, as well as horticulture industries. Rockwool's core business is in insulation, which possesses outstanding fire, acoustic and thermal insulation properties, as well as a lifelong durability. Now, without further ado, I would now like to welcome our very first speaker to start us off on today's wonderful learning journey. So let me introduce him first. He is Mr. Jay Fong, Managing Director of LWC Alliance Private Limited, and he will be sharing with us about creating bespoke and iconic precast facade through collaboration with architects. Mr. Jay is a trained architect who had practiced in HOK in San Francisco and Bechtel International in the early 1980s, and now regularly lectures at tertiary. For nearly 40 years, Jay has been promoting custom-made precast concrete facades to developers, architects, and contractors in this part of the world, and he has worked with many renowned architects such as Safdie Architects, Woha, and Heatherwick Studio to deliver concrete facades that are iconic and bespoke. Let's welcome Mr. Jay Fong, please.
Thank you very much, Sarah, for your very kind introduction. And also I would like to thank Timothy of Meinhardt Façade for liking my work and to invite me to speak in this webinar. I was impressed that I was told there are about 500 over of you signed up for this webinar. And I'm so pleased to be sitting in my office in Singapore and being able to meet all of you wherever you are. I think most of you are in Jakarta, and of course some are from Malaysia, and one of my fellow speakers is from France. So thanks to Zoom, here we are. Okay, allow me to share my slides now. Can you all see my slides? Good, thank you. Thank you, of course, to Glasstech, Asia, and PERAFI, and Giorgio and Adrian of Glasstech working so hard, trying to coordinate everything, chasing for all the materials to make sure that we submit on time and to make this webinar a success. The title of my talk today is how we can create a bespoke and iconic precast concrete facade through collaborating with architects. Now, very briefly, I will explain the process that I went through in collaborating with the architects and the outcome of this precast concrete facade that is bespoke, and also many of them are iconic. And of course the process that I went through in developing this precast facade panels, and we are focusing on three primary issues. They are the colors of the precast concrete facade, and then the textures. Texture meaning whether they are smooth or they are rough, or they are half smooth and half rough, and so on. And of course, and there is the profile. That means the shape or the form of the concrete panel facade. I've chosen three projects to share with you. The first one is a Troika. It's a condominium project in Kuala Lumpur, Malaysia, designed by Norman Foster and Partners with the local architect GDP. The second project is in Singapore, is the new state courts, and is designed by a firm based in UK called Sri, and in collaboration with the local architects Multiply and CPG. And the third one, the Hive, in the NTU, National Technological University in Singapore, and designed by Thomas Hedderwick of the Hedderwick and Studio. And this happens to be, I understand, one of the favorite projects of Timothy. So and he makes sure that please focus on this job. So I'll try to do that. Now, the first job is the Troika in KL. It is a condominium project consisting of 3 towers, each one about 40 to 50 story high. And then our work is used at the shear wall, the black walls here, that you can see from your bedroom. When you sleep, you are next to it, or you can see them in your living room or in the balcony, and also from a distance. Now, this is what one of the panels look like. It's a precast concrete panel. The natural concrete, there is no paint, there is no skim coat, there is no plastering. This is the honest expression of the concrete. But how we can do this is not so easy. You have to be very clean, and color has to be very uniform to meet Norman Foster's requirement. I'll try to explain that in the next few slides. In order to make sure that the color is consistent, because we're not painting the panels, all the raw material has to come from the same source. For instance, the granite aggregates had to come from the same source. You can't use granite here from this quarry today and then the next batch from another quarry, because a different material such as the granite or the cement or the sand will alter the color of the concrete panels. And to make the panels, we have the mold. In this case, this panel, the mold size is 1 meter by 3 meter. And we pour the concrete after we have chosen all the mixes. And then there is a U-shaped panel that is done in this mold. It's made of a steel. And this is the panels that are cast from the steel mold. And they are used, in this case, you can see the U-shaped panel on the end, and then the flat panels in the center. What I want to highlight is that the Norman Foster had a very strict requirement on the color. He has, and then on the uniformity of the texture. And for the color-wise, he doesn't allow any black mark, which is natural in concrete, such as the effect like a marble. He doesn't allow that. So anything that is bigger than, they say, if you have a black blotch that is bigger than a 50-cent coin, that will be rejected. And all the panels have to be compared similar to the one that we sent to London office, the circle in the red, and the color has to be very consistent, ranging from the lightest gray on the top and the darkest gray that he allows on the bottom. And you can see the lightest and the darkest is exactly the same color. But such is the Norman Foster's requirement on this particular project. So up close, it looks like a stone. You can see all those white marble chips and the gray marble chips, and then the gray cement in between. And from a distance, it looks very clean as a shear wall that goes up to 40, 50 story high. The second project is a new state courts designed by a Chinese Singaporean, Chris Lee, but based in UK, together with his partner Multiply and the local architect CPG. Our work is the red panels that is in between all these white beams and white columns. Now, this is the original concept during the design stage. Architect wanted this terracotta, the natural terracotta in this curved shapes and form, and the color is a bit uneven. However, the terracotta panels that they sell mostly are flat panels, and the color is very uniform. Of course, you can make the terracotta panels curved, but I think the cost is very high. So that's why it was changed to a precast concrete. As you can see here, the color of this rendering shows there's only one red color, and the texture, we just there's no mention on the texture, and then the profile is the groove line, the in and out, and the groove line is the width is consistent throughout. It's only one width. However, after we got a job, the architect wanted us to revise the design. So his new design concept is to want to make everything very random. What I mean by that is the color will be more than just one color. It becomes from one red color to 4 different terracotta colors, like in the roof tile that you see. He said, Jay, this is, can you do this? This is the terracotta tile of this roof tile that he saw, that he liked. Say, I want to do something similar to that. I said, yeah, maybe I can try. So the color has to be 4 different colors, and the texture will become, it will be slightly rough. And the profile, meaning the ins and out, those groove lines have become from one width to 6 different groove line widths. So when you combine them, it'll be all very random. And throughout the building, they different. He would want a different color scheme for different floor. They had chosen 4 different main color. For the terracotta, you can see them here. Color 1, 2, 3, 4, and each one of the terracotta color will consist of 4 different shades of the same color. So altogether, there are 16 shades that we need to do. And it gets to be quite complicated. As you can see, we have to do lots and lots of these small samples for him to choose. And now Chris Lee is based in London. So we have to Skype. This is the before COVID and before Zoom. And we have to Skype. And sometimes we have to use our handphone to take photos and then share the photos through the handphone. But we have soon come to realize the iPhone and Samsung phones, they have different colors, so we have to use all Samsung. We all agree to use only Samsung phones when we share the color, so we can see the same. We can discuss on more accurately on the color, because we're talking about very fine a distinction of all the shades of the terracottas. And we have to do, and we have, after all these panels that we have cast, we have to do 3 sets of these control samples, 1 to be kept by the main contractor, 1 by us, and 1 by the architect. And this is the based on the architect's drawing, we have to do a visual mock-up. As you can see, we are doing this mock-up panel here in this red box, and each panel is about 6 meters tall, and you can see all the panels have different width, and then also the colors, there are 4 different shades of the same terracotta colors, and then the groove lines, they are all uneven, so the whole thing looks very random and very natural, yeah, rather than just a single color and a single width of the groove lines. And the panel, there are 3 types of 3 widths of the panel. The widest one is 1.8 meter, and then there's a 1.2 meter wide, and then there's the 900 meter wide. And after the job is done, the visual mock-up is approved. All the team got together for group photos, and then the gentleman that you see in the middle is Chris Lee of Surrey, surrounded by the local architect CPG and other consultants on the job. And the VMU on the visual mockup, the architect had to show to URA the effect of the night lighting. So it was done on the visual mockup that we have done, and it doesn't look quite different from the actual wall, with a night light effect. And the panels are transported from our factory based in Johor to the site in Singapore, which is about, by lorry, it's about an hour drive. And you can see how the panels are stacked one on top of the other. And each panel being 6 meters, so the whole width of this particular floor is about 12 meters high. And if I stand here, you can see that I'm only up to somewhere here. So you can see the scale of this is actually quite impressive. So we were able to change from the original terracotta design to a uniform red color, a single color, single groove line precast, to something that is very random and very interesting. And all this design upgrades was done after we got a job. And recently, this project has won an award. Now, my third project is the Hive in NTU in Singapore. It's designed by this gentleman in front of the building, Mr. Thomas Hedderwick. This project, we say the facade is iconic because this project has become an icon for NTU. Everything that NTU uses in the recruitment or in the advertisement, in this case, this Facebook page, is all they have used this the Hive as the icon for the school. Now, before I get to the facade design, the precast design, because this project is so interesting, not just on the facade, but also on the layout and also on the form and also on the interior. So I'd like to just spend a few minutes talking about some of the interesting features about this project. And many of these photos are just taken from the website of the architect, such as this one. And this is a project. The red spot is the campus location, is location of the building, and the total build-up is about 14,000 square meter, and at a cost about Singapore dollars, about 45 million. Now, $45 million. I was told by the architect, it's the cost of a car park structure in Singapore. So in other words, he is working with a very tight budget on this project. So so everything that was done for this project, both interior and exterior, all natural concrete, without any paint or any of those additional claddings. The layout consists of 12 pots, like a flower petals. There are 12 of them, and also 12 towers, and each tower about 8 floors high. And this is what the structure looks like. You can see all the columns, they are all slanted, they're all sloped. And every column has a different different slope. So it is a very complicated product. I mean, it's very difficult to build. I was told by I was told by the main contractor. And this is the interior of the atrium. The atrium is all naturally ventilated, which is and when you are inside, you don't, even without the air conditioning, you feel still very comfortable because of the natural ventilation of this building. So it's very successful in that regard for a tropical design. And in one of the talks by Thomas Hedwig, he mentioned that he was explaining the concept of the layout. You can see that he said the traditional in a traditional school, you have a long and narrow corridor, and each room is a squarish room with a lecturer standing in the front and a student all sitting at the back. Now, in his concept, in his design, he has made all the classroom into like a flower-shaped petals, round, and then very irregular and very organic. You can see that this is the interior of the classroom. The classroom is not squarish, it's round, and all the tables, the chairs, they're all movable. So there's no front, and then there's no back. And then the blackboard, the traditional blackboard is all around the wall of this classroom. And then the lecturer does not necessarily stand in the front, but she can be anywhere. So this is the new concept of learning, of a classroom design. And another feature I was told, I heard in his lecture, is that they have this corridor that connects all these pods, and the corridors are designed to allow and to encourage interactions among the students. And he said, Thomas Hedwig said in one of his talks, that the one of the minister told him that he would like the design to promote and to increase the birth rate of Singapore. In other words, getting all the boys and girls, getting them to meet along the corridor and so on. So, judging from the photos I can see online and all the wedding photos taken here and here, I think Thomas has done a very good job. Anyway, coming back to the design of the facade, I'll show you a 1-minute video by Miss Kate Goodwin. She's a lecturer and as well as an architect from UK.
There's 1,050 of these panels that make up the outside of the building, containing each of the sort of learning pods or classrooms. To create this precast concrete panel, they had a piece of formwork that was laid out, and they realised that to make something special of this piece and this concrete, they had literally the surface of the concrete to be able to play with. So you'll see that it's not that normal sort of grey, heavy concrete colour. They've actually added a pigment to the surface, giving it a sort of slightly light pinker look to it. Each of these panels is unique, and they were laid out with a series of pieces of rubber that were laid into the formwork. You'll see there's moments of shininess, real sort of roughness that comes about. What we're seeing here is the final panel. It's one of the final panels, but you can imagine in kind of getting to this kind of quality and surface, there was numerous, countless one-to-one mock-ups that were done to sort of get the exact pigment, get the exact texture that they wanted to refine it.
Now, after I got a job, we have Thomas and I have changed the facade, and I'll share with you the process that we have gone through. We have changed the colors, and we have changed the profile, and we also have changed the textures. Now, on the color, originally he liked something like this. Say, hey Jay, can you do this kind of cotton steel work? I said yes. So in his rendering, he actually got this design shown. You will look, but now, however, it looked like this. So now I got my artist to Photoshop. Now how it became from this design to that, I will try to explain. Now Thomas saw a few samples that I did, and he liked these two. But he said, Jay, can you make this gray a bit more beige, the one on the left? Or can you make this beige a little bit more gray? I said, sure. And the next time that he comes to site, now he comes to Singapore maybe once every month or once 2 months. So I must get the color right. Each time I must get the design change right. Otherwise, the process would take of a long time. Here you have the most gray, and here you have the most pink. And he chose the most pink. And this is the color that he's chosen. Now, the profile, he sent me this photo. Hey, Jay, can you, this is the job that he liked. This is the Perot Museum of Natural Science and of Nature and Science in the US. He said, Jay, can you do this? He liked this. Every panel is unique. And then, all these joints, they are not vertical, they are sloped. I said, yes. So he changed his profile to something like this. Is all curvy, is all a wavy, and each one is about 3.2 meter tall and 2 meter wide. Now the next thing is that we look at the textures. There are two different textures, the rough and smooth on each panel. The recessed, the curved part, the darker part is the rough texture, and then the lighter one is a smooth. And then he sent me this rendering with this detail blow up. Then when I looked at this, I said, oh no, because you can see that the color here is quite random and looks like a stone, and it has all the pixels. Now, the ones that I did was very uniform. So from a distance, the one that I did, where I show him, which he has approved, would look very flat, would look like a paint. It wouldn't look like this. So when I explained to him, next time over a cup of coffee, he said, Jake, this is what I want to do. He was sketching his design on this packet of sugar. So I pretended that I understood. And the next time he came, I showed him a lot of samples, some new, some from my factory I've done in the past. And from that, I picked about 10 panels. I said, Thomas, if you were to combine all these panels, we probably can achieve the effect that he was looking for. So that's a color. And then I'm trying to do these voids and holes like a natural travertine. Now, how I did it was I stole this packet of Himalayan rock salt from my wife's kitchen. And then I pour this salt onto the mold, and I pour the concrete. And then after the concrete is dry, I would wash with water to dissolve and remove all those rock salt. So I get these holes. Now, of course, my actual project, I have to use this garam kasar, which is a lot more cheaper than the Himalayan rock salt that I use for the sample. And then to make the surface even rougher, I stole from the kitchen a packet of baking soda. I mix with water and pour into the mold, and then I pour concrete. So when concrete comes in contact with the baking soda, it will destroy the surface, making this kind of a pattern, these broken surfaces. And when you combine them, you look something like the mock-up that Thomas is commenting. And what he said was, translation, but a bit darker, please. And with that, we did all the small panel from a lighter to darker, and then he chose the one that is most dark. And for the recessed part, the color and texture, he has chosen the one that is that is the most dark. But he has one more comment. But more brown pebbles and less black. So with that, we were able to do the VMU, the first panel for him to review. So he looked at up close, and then well, actually, when you come to look at it, the color is very similar to the image that he has shown me before. And then he stood from a distance and then viewed it, and then he approved it, signed it off, and we have to produce them, and we install them by mobile crane. And this is the fixing method. You have 2 points that sits on the slab, and then you have 2 points that is held at the top for a restraint. And this is the finished project. And what I wish to highlight is about 1,000 over pieces, and each piece is unique. Every panel is unique, and this makes our work very complicated. But because of this richness and combination, it makes this project very interesting. So here it is, the final project. I mean, they find the photo of this project. I once asked Thomas, what is your favorite project? He said, oh, it's NTU. That was in 2015. But he said, this is my first completed projects. In the past, his projects are all bridges and the UK, the hall in the Expo 2020. This is his first permanent project. But he said, I also like it because it looked like a Japanese pottery. As you know, Thomas Hedwig is not trained as an architect. He was trained as an artist. So he likes, the handiness of the quality of this project. And his work has been shown around the world, including here in Singapore and in the US. Proud to say that my panel sits right in front of the London bus that he has designed, right in the museum. So I'm very proud that my concrete panel is actually shown in the museum. And he also used this design for the book cover, and obviously he quite liked my work. So with this beautiful photo with the beautiful panels, and I would like to end this and end my talk. Thank you very much, and over to you, Sarah.
Thank you so much, Jay. Thank you for the wonderfully inspiring presentation. It has really opened our eyes to the vast possibilities in concrete that I think was so interesting, how you had to, really think out of the box, how to work, like even use salt and baking soda. That was really cool. And hopefully all of us will now have more ideas in terms of how to even integrate glass and metal with concrete. I hope we'll see more of that in the future as well. So in the interest of time, we're going to move on to our next speaker. We would like to welcome Ms. Sandrine Guibert, Head of Glass Market from Novacell, who will be speaking on the benefits of temporary protective film for glass facades. Ms. Sandrine has been working at Novacell since 2007, beginning as a marketing product manager. Today, she is the head of Glass Market with experience in developing protection solutions for Glass Market and providing worldwide support for sales and customers. Sandrine is in charge of the development of green protection solutions for all surfaces, and she holds a diploma in chemistry and a master diploma in business. Ms. Sandrine, please share with us your presentation.
Thank you, Sarah, for your introduction. Can you hear me clearly?
Yes.
Thank you. Let me share with you my presentation. One moment, please. Can you see my presentation clearly right now?
Yes, there is a little box on the bottom.
Still this little box. Is it better like this?
It's on top.
A moment, please. All right, I think this is okay right now.
The box is right in the middle. Okay, this is good. Yeah.
Thank you. So good morning, everybody. I'm pleased to share with you my presentation this morning, and let me introduce Novacell. First, Novacell has 3 business units. The first one is the worldwide leader of protective films, with its 2 brand names, Novacell and Maintape. Novacell films are protecting almost 100% of the surfaces involved in the construction industry, like metals, plastics, wood, glass, and so on. The second gathers the fabrication of industrial tapes, almost for the paper industry, food and beverages industry, and electronics. At Novacell Performance Coatings, we produce coated papers like heat transfer papers for the textile industry, for instance. And the third unit designs and assembles machines to apply films on the surfaces. Wolco and OMA are leading brand names in that field. Novacell is the worldwide leader and actor located in the 3 continents with 11 production sites and 17 service centers and branch offices. That means there is a local contact almost everywhere around the world to answer your needs. Novacell, this is more than 700 employees. At Novacell, innovation is key. More than 25% of our sales are done with new products. In 2020, this led Novacell to a very good financial performance with a turnover that exceeded 217 million euros. We're lucky to serve more than 3,000 customers all over 90 countries. Novacell is a responsible industrial actor in regards sustainability. Many commitments have been signed. On top of them, the Global Compact of the United Nations and also local ones. Quality insurance is also a strong pillar as well with ISO norms. Performance is controlled by CEDEX organism, more specifically labor laws, health, safety, ethics, and environment. Now, let's go through the world of protective films, and let me explain to you what is it very important to use protective films. First, adhesive protection avoids damage to new surfaces that have been resource intensive to produce. It is better to protect than to remanufacture. This is good for the environment, but also for the brand image and for the costs. Second reason, sometimes protection films are necessary in the production process. Without protection films, some factories have to stop their production line. Another reason, protection film protects the surface through a succession of transformation of the surface, from surface production to installation, going through the transportation. It also avoids the accumulation of packaging. Again, this is better for the planet and costs. Finally, when they are removed from the surface, protection films reveal an intact surface. Films are a kind of guarantee. What is temporary self-adhesive protective film? On top of the drawing, there is the film. In yellow, the surface. Let's focus on the film. In red, this is the plastic layer, also called carrier. It is made up of one or several layers of polyethylene. This side is a shield against dirt, scratches, water, chemicals, and so on. In green, this is the adhesive layer. This side is in contact with the surface. This adhesive layer is formulated to stick on the specific surface for a certain time and to be removed easily without leaving any residues. It is necessary to adapt the formulation in function of the use of the film and in function of the kind of surface we protect. Actually, behind the very basic concept, there is a very specific chemical technology. Now it's time to focus on IGU protection. Before going on, I think this is important to define the words I'm using. IGU stands for insulated glazed units. You can see what I mean thanks to the picture on the right of my screen. Insulated glass, usually speaking, Lowy glass, the kind of glass that is used to create windows. The protection of IGUs can be done as soon as they are produced in the factory. Then the protected modules will be installed in the window profiles at the window manufacturers or directly on the facade. Windows are among the first elements installed in the new building, protecting it from the outdoor environment. For that reason, glass is very sensitive to damage during the remaining construction work, which may take months. Protective film is an amazing shield against all types of environmental attacks that can face glass during the construction. For instance, cement projections, paint projections, silicone, grinding sparks, and more. Thanks to protection films, no more cleaning or replacing of IGUs are needed at the end at the construction site. No more late fees or penalties and no more disputes between glass installers and customers. Customers are more satisfied and returns are almost non-existent. That's why building producers, architects, window manufacturers, IGU manufacturers are very interested in using this kind of product because it reduces construction time and enables to deliver a clean building. Usually speaking, IGU are protected in the factory by IGU producers at the end of the fabrication. Films can also be installed by window manufacturers, sometimes directly on site. Novacell has designed a full range of films dedicated to the protection of IGUs. The difference between the four films can be the color. There can be clear, transparent, or blue. In any cases, they are translucent. They are all leaving daylight penetration into the building. This is very important for the construction because it leaves light penetrate into the building during the construction. The other difference is the thickness of films begin at 36 microns to 70 microns. This thickness will be important depending on the way the film is laminated. And the third difference is the outdoor guarantee, 6 months or 12 months, depending on the duration of the construction site. The film selection is done in function of the needs and constraints of the customer, the way the film is applied, the average duration of the construction sites. Whatever the film reference, they are all climates compatible. Let me show you this small illustration. Films are designed to sustain all kinds of climates, water during winter, and also summer. Our films are easy to peel off without residues. Recyclability is also a key point. To sum up, NovaCell protective films are a safe solution to preserve insulating glazing all the way. Since films are installed since the beginning of the fabrication of the IGU, glass is protected all the way from the fabrication to the end of the construction work, going through assembly into the carpentry at the carpentry factory. They are also sustain joinery installation and transportation. Our films are scratch resistant to adhesives, cement, paint, and grinding injuries. They are all climate compatible. They sustain warmth and humidity. They allow daylight penetration into the building. It's possible to use the same film for inside and outside use. No need to change the film. They can be removed from the surfaces easily without leaving any residues. And they can stay on the glass during 1 year. So the benefits of protecting IGUs are numerous. Less replacement of damaged glazing at the end of the construction, fewer disputes between window installer or glass facades and customer. They are leaving considerable time and money savings, and they guarantee customer satisfaction. This is very, very important. How our films are tested. NovaCell has got an internal lab that designs films and performs some tests. For glass application, protected IGUs are sent to natural aging sites in Florida and Australia. Those places are famous for their special climates. Our films are tested over there for 1 year in real conditions. Internally, we accelerate this natural process with a weatherometer device. We also evaluate the impact of UV on glass thanks to QUVB tests. External tests are also possible according to specific norms. For instance, we can evaluate and prove the aging tests on our films. Our films are used by famous customers on the glass market. I give you some names: Warden Glass, Saint-Gobain, and AGC as the first customers. Lamination of the protective films on IGU is a key point to consider. Depending on the kind of actor that is applying the film on the surface, there are many solutions to apply this film. First, this is possible to apply manually the film on the glass. This can be done directly on site or at window assembler. I can show you a small showing this. On this video, you can see that it's very easy and quick to laminate film by hand on glass. This is done with a plastic squeegee, simple plastic squeegee that enables to stick the film on the glass and to cut the film also. If the applicator is bigger, this can be also a solution to apply the film with a machine, with an horizontal machine. This lamination of film will be done offline. For bigger IGU producers, for instance, we will recommend to use an industrial laminator, vertical laminator inline. This will enable to keep the capacity of the installation and to protect more IGUs. I'm going to show you this video and you will be able to figure out how it's possible to laminate film on an industrial way.
Sandrine, we are not seeing the video.
Oh, really?
Yeah.
Oh, I'm sorry. I'm blind when I'm doing my presentation.
No worries.
One moment, please. I'm going to share this video with another. Are you seeing it right now?
We can, yes, now we can.
You can right now?
Yes.
That's okay?
Yep, it's good now.
Perfect, sorry. Let's go back on my presentation. I hope you could enjoy this video. Sorry. What happens with my mouse? All right. So from my perspective, the main assets of these machines or its speed, 35 seconds for a cycle time. It's fully automated. It protects both sides of the IGU at the same time and leaves free edges around the IGU to enable to install it into the frame of the windows. Once IGUs are protected, this is still possible to handle them with vacuum lifting devices, as you can see on the picture on the right of my screen. This is very important to point out this. To finish, at Novacell, we have also other solutions for the protection of glass. In the 4-glass range, we have 2 other films, one dedicated to the protection of coated glass, and one film that is able to protect glass during the acid etching process. We also have a permanent safety back film. This one is dedicated to mirrors and lacquered glass, and it is there to retain glass pieces in case of breakage. At Boston Tapes, there is an edge sealing tape, the green tape around the IGU, as you can see on the picture. And soon we will launch a new protective film made with 20% of recycled content for the protection of IGUs. This will belong to the Oxygen range, the new eco-responsible range from Novacell. My presentation is finished. Thank you to you for your attention. If you want more information, do not hesitate to contact our Asian office. If you need more information about our glass solutions, I invite you to visit our website, Novacell for Glass. If you need more information about the lamination machines, you have the link to visit their website as well. We are present on WeChat and on LinkedIn. Do not hesitate to get in touch with us. Thank you for your attention.
Thank you. Thank you, Ms. Sandrine, for sharing details on how we can protect the value of glass from manufacturing to construction sites and increasing our manufacturing efficiency. So we would now like to invite Mr. Rafael Pasaribu. He is the owner of Abode Design to share with us about his work. After receiving a degree in architecture, Rafael grew in ranks, beginning from assistant architect at Forum Architects to principal designer at Axis Architects Planners. Rafael then formed his own practice together with his partner in 2006. And since then, Abode Design has grown to now manage a wide spectrum of design with its core practice revolving around residential, commercial, and hospitality projects. Rafael also regularly speaks at architectural talks and seminars. Mr. Rafael, please.
Thank you. Hi, everyone. I hope today's the materials that is prepared from me will be something to contribute to the community. Without further ado, I will share my screen to start my presentation. Okay, today I will present you the new indoor multifunction stadium at a sport complex that is located at the center of Jakarta. And as a background, this is a fast track project which is commissioned by the Association of Basketball of Indonesia and also the government of Indonesia, because we have an event due for August 2023, the World Cup basketball event that will be co-hosted by the Japan, Philippines, and Indonesia. So up to now, I haven't got any idea whether the final will be hosted in Philippines or in Jakarta. Now, so what you see right now basically is the progress that currently ongoing with the construction on site. You see the building here. Selections of materials right now are being discussed. What I present to you may not be necessary the final selections that is selected by the contractors, because how we deal with government project here is quite different from other, I mean, in other countries, whereby we are doing the basic engineering design. From then there is a schematic design for the schematic design, and then after that there is technically we handle differently, whereby there is another consultant that is commissioned by the contractors to continue our works. Okay, so let me walk you with the background of these new structures. The event, the building itself will be located at the Gelora Bung Karno. Gelora Bung Karno is the main stadium whereby usually we have our last Asian Games 2018, if I'm not wrong, were hosted in these buildings after much of renovations. This is started in 1960, whereby we had the Asian Games the fourth. Okay, the view is very empty because that's the only structure, along with two more stadiums that is hosted, that is designed to host badmintons and other stuff. Okay, this is the current view. 1990 view. We still have much greener structures because this also act as a what's called a lung, the green lung of Jakarta, which is currently we have less than ideal numbers. And then the government tried to recover the green area based on other facilities they can recoup from their inventories. And then because this one commissioned by the first president, the whole structure here consider a conservative area. Conserved area. I mean, that is a preserve, even though we have a lot of renovation works for the event of Asian Games, but we try as much as possible not to intervene with the characters. Now, that is basically what we are going to do with our new building, because this building would be considered the first and the last structures in this sports complex. The architects that is basically part of the heritage association, basically they have objections to have a new structure here, but because of the location is very strategic, so the government decided that this will be the best decision they have with regards to whatever controversy may arise later on. Now, we try to create something that is very short in time, but try to meet the international standard, especially from FIBA. Okay, and then we come up with something that is two massing, basically the top and the bottom. The bottom or the podium reflects the current structures of the characters. We have a couple of structures that basically contribute to the characters that we have for the podium. But the top, where is the head of the stadium, basically represent the craftsmanship. We try to create a narration whereby the craftsmanship basically is part and parcel of our daily life, and then that basically will make people easily relate to the building. So try to ease the controversies very much from the local folks. Okay, what we have right now, the building will be on the northwest of the main stadium. Okay, and then we have a lot of facilities after the fourth Asian Games and the last renovations. But basically, this the only structures that is allowed based on consensus that is given by many stakeholders. Okay, this is the first story plan. Okay, FIBA is as what we have with other stadium that is designed. Usually, they have very strict zones. On the left side, actually is services, and then also the parking area for the athletes, and the lower part where we see the orange color basically for the publics. It's open plaza, where we have on the left and right escalators that lead people to the lobby and the second floor, and then the green area is for the executive parking. So whatever event supporting facilities will be hosted and at the ground floor, that include the media, changing room, and so on, also along with the official rooms and executive lounge. Coming into the inside area, the red color represent the MEP equipments, and then this is what basically the supporting facilities for the flying field. We designed this with consideration that not only basketball to be hosted, but also like ice hockey and other indoor sports. Okay. Second floor, where the tribune starts. The tribune starts basically, there is part of the tribune that is accessed from the second floor, but going into the first story, whereby it is retractable seating. Okay, it's a telescopic seating, but others basically is a corridor at the perimeter rings, and then from the corridors we enter the tribunes, and we have two training field on the left side, and then the commercial on the blue colors on the right side, and the yellow color is basically where the public will access the internal corridors. Okay. Our ongoing discussion with the appointed consultants, basically there's some changes, if you see this drawing, happen to be on the core of the lift core and the staircase core. Okay, this is the third floor, whereby the third floor we have the executive box. Okay, executives, basically the presidents and so on will be stay at these third floors, and then the circulation of the third floor will be isolated from the public access as part of the requirements. And this is the fourth story, whereby we can see also other additional massings on the left and right will act as a place for MME equipments. And this is the top, and then this is numbers of tribunes. Okay, so this is the buildings from the north and south. The north, basically we can the facade will face the national broadcast televisions, and south elevation basically we can see from the main stadium. There's two different things, because people will be coming from the south elevations. Now the south elevation, the podiums, we need to tie back with the surrounding characters. And the top, basically we have two options for the finishes. One is the aluminum panel, not aluminum composite panel, but aluminum panels, and the other one is a stretch membrane. We can say some of it come with the brand of Ferrari and so on, that it is translucent materials that allow fissions from inside to outside. Okay, and then also allow transfer of air, because we actually asked to make this building as efficient as possible for the energy consumptions. That's why the corridors at the fourth floor and part of the third floor will be a natural fan. Okay, so being natural fan, basically we try to create, if it is aluminum panel, it will be perforated. If it is stress membrane, like the fabric from Ferrari, then basically it is already a breathable materials. So that comes in all panels that going on, just like we call the form basically mimicking the daily food containers that is carried along by Japanese people, especially during the event of celebrations. Some sections we had here, the controls of the authority here controls the height, because we don't try to compete with the main stadium. So the main stadium, the perimeter height is about 36. We are pushed to 32 on the eve of the roof. That basically is controlled by the governments. Okay, so if we see this one, how the building works, quite straightforward. Okay, along with other 16,000 capacity seating for the stadium alike, this is the most compact footprint ever, because we are about 15,000 square meters GFA. Other come up starting at least 70,000 square meter and beyond. We are constrained by the size of the location. That's why this is very compact. Okay, and then whatever this that we put here, still we try to adhere to the international standard given by FIBA. Okay. So this is the skin sections. So the skin section that allow some maintenance access. Okay. At every skin level for easy maintenance, and we still provide access from the top for gondolas, but prefer to have an access at every level of panels. Okay. Okay, so this is some more detailed sections how this elevation and then its panel work out. We work with Meinhardt as our facade consultants. That's why the idea is not to create from composite panel, but aluminum panel itself directly. So it need to be sourced to the suppliers, and instead of there is some benefit that given by the aluminum panels. Notably, we had incidents in Jakarta whereby one of the government buildings had fire incidents, and then some of it basically contribute by the utilization of aluminum composite panel, which is non. They use the non-fire rated materials. So the issue here is basically we try to avoid, because the authority asks us to really concern about selections of materials. So that is one constraint that we have here. Okay, this is another view. This is one panel. So the panel is basically about 3 meter over 3 meter by 1.2. Some views, okay, that we see here. So with this natural fan situation, we try to borrow as much as possible the lights from outside. Basically, the sports complex official requires us to create building that is zero maintenance. To us, basically, we ask. I mean, like there's no building which is zero maintenance, but minimum maintenance, yes, because zero maintenance means that you don't come up with a budget to maintain the buildings, which is basically is a big question. None of the materials in Jakarta so far that I know, even even a glass, they come up, they actually after several years, because they don't provide coatings, then there is a, you know, some stain happens because lack of maintenance and so on. So yeah, basically still maintenance required for these buildings. Some other views on others area. Okay. So we basically take out whatever unnecessary constructions, just leave it bare essentials for the building to perform. This is a very zoom, the scale of the panels you can see compared to the person sitting there. Okay, the elevations from if we actually put in real use, we can still see whatever structure behind the screen. But the last top two, we use the solid panel instead of screen, because we don't there's no necessity to provide the cross ventilation at the top, because it's part of the utilities. Some view below, you can see the structures that come from the existing building. So that's basically the contributors to what we have. We have very modern approach in the beginning with some fee structures, columns, metals, but then again we have challenged by the heritage, and then because they cannot approve that, if we don't get their approval, then the building cannot go to the construction states. So we have very interesting characters from existing building here, but not everything can be replicated. So yeah, we just borrow the column characters and so on here. Okay, the panels, the colors that we choose, yeah, and that basically also control. But we insist to have the champagne gold colors as an accent to the narration that we built, that this one is a craftsmanship with this bamboo colored things in wood, and then that also make a statement that this is the first and the last building after several years that is constructed, and be part of the modern characters that is injected to this area. Other than aluminum panel, we also use the roasters. There's roasters basically also provided by the next door facilities. So I think it's best to make it make it part of the building too, but only slight part, because the rest is very much controlled by the aluminum panels and glass. Okay, this is the view from the south. Okay, this is from the main road. Okay, some kind of features for like a green wall and so on is introduced here. Formally, they want something more commercial oriented, just like a billboard, but then the heritage also thinks that may jeopardize the whole mood of the area. We insist to actually take out the fence, because we feel that this should be a permeable space. People are invited, but then there's some security concerns that is happened, so that's why they still want to retain the fence here. Yeah, the view towards the main stadium. Yeah. Some area on the roof are required to be green or exercise to be a facility come with green. So basically we introduce the commercial area at the rooftop, so people can go around and enjoy the greeneries that is provided. If this is just a greeneries, I don't think people will come up to the level of this and then doing something. But if there's a sense of destination happen, we create the a hall at the third floor here on the further right. That basically makes people want to go up during an event. Okay, some lighting provided for the building. We try not to make it too much color fanfare and so on, because again, the whole sports complex basically very much controlled by the authority. Okay. So I will continue with some animations. Sorry, I got to stop the share here, and then I start with, sorry. Wait a minute. Okay. Screen. Oh, I cannot see. Oh, here.
Guangzhou. 6 on the shot clock. Here comes Brown. Brown, step back for 3. Oh! Can you believe it? What a 3 from Brown!
Okay, with that animations, I guess there's a closing. So from the animation itself, we can see that the multi-event basically will be, because the situation that is very strategic in Jakarta is going to be, popular with concert and so on, that is estimated. And then by the not also the government but also the operators to be. So that's why during the presentation we propose to see what if let's say a concert like BTS hosted there with like 10 to 12,000 visitors happen. Okay. So thank you for the time provided to me. I hope that one something that is can contribute to the community. Thank you.
Thank you so much, Mr. Raphael, for giving us a behind-the-scenes look into this unique project, very unique project, and also for showing us the thought process behind the choice of the facade design and materials. So now we've come to our last speaker. Last but not least, let's now welcome Ms. Azani Azmi to the stage. Ms. Azani is the technical specialist at Rockwool Asia, and she graduated with a bachelor's degree in electrical and engineering, but joined the building trade out of strong interest and passion. From a time at ProMat Building Solution, focusing on passive fire protection and fiber cement, she then moved to Rockwool Malaysia in 2017, and now she provides technical support on stone wool insulation products and systems. Today, she'll be sharing with us on the topic of fire safety and facade cladding. Ms. Azani, please.
Okay, thank you so much for the introductions. Hello, everyone. All right, I think you all can see my screen.
Yep.
Okay, good, thank you. Okay, as the host mentions, for my part, in this presentation, I will just give a bit of introductions. What are the fire safety requirements when it comes to external wall? Even just now, Mr. Raphael he's also mentioned that now people start looking up in terms of building materials. They want, because of few fire incidents that happens throughout the world, they want to raise up to choose a better building materials to build in any building or designs. A little bit about our companies. We are multinational companies with 80 years of histories. We produce stone wool insulations for buildings, for industrial applications, and even special industries such as automobile as well as railway industry. The special things about our product is, if you recall back in the previous video, is actually our product mostly is not visible in naked eye when installed in the buildings, but one of the important building material as it enhances the building performance, either in fires, acoustic, or thermals, and a way is provide comfort to the occupants. In Asia alone, we have going strong with 20-year presence. And our office in Indonesia actually located in Jakarta. Some of you may know about Rockwools. Rockwools is actually a company brand. It has been in our name for the last 8 years and registered in over 60 countries. So usually when it comes to the insulation name, generic name, we would like to call it as mineral wool, stone wool, because the product is made from the stone. That is the main components. Mineral wool, rock, space wool. Okay. Right. Let's start straight away with fire resilience. Okay, this is for this today topic. Here is actually what I want to highlight is a few external fire incidents that happen, and how can we make this a learning process to build and design a safe building. Okay, we have here Jecheon buildings in South Korea. Fire happened on December 2017. It's actually an 8-story building. The fire actually happened on the ground floor due to electrical failure and spread throughout this 8-story due to combustible cladding, which actually unfortunately killed 29 people. It's one of the deadliest fire in Korea history. And Lacrosse apartment is in Australia. Fire happened in November 2014. It's actually happened late at night. Okay, it happened due to actually cigarette butt causing the fire spread through the external combustible cladding, which is the ACP actually consists of polyethylene core. Luckily, no casualty because people are able to evacuate early. But the thing that I want to highlight here is the aftermath. The authorities actually found that the external cladding is actually not compliant with the combustible requirement and asked it to be removed. And at the same time, the owner has been awarded more than 5.7 million in damages. And the one who actually have to pay the damages, the most actually percentage is the architect, the certifier, and the fire engineer, consists around 20-30%, not the builder. So this actually sparked notion that architect also has to bear the responsibility of the safety of the buildings as they are the lead consultants. Grenfell Tower, June 2017. I think most of people know about this incident because this is an incident that actually sparked in terms people start to talk about fire safety in the external wall. Again, fire happens due actually because of the malfunction on the level 4 of the refrigerator. It spread very, very fast of all these 20th floor. And unfortunately, there are 72 fatality. Okay, the fire is actually happened is because of they have this SCP panel. The building is actually fixed with SCP panel with polyethylene core. This SCP panel is actually it actually acts as a source of fuel, and at the same time, this flammable insulation it caused the melting and dripping and caused the fire to spread. And behind that SCP panel, they have this what you other foam insulation, which is the PR and phenolic foam, that also contribute to the rate and extend the vertical fire. And currently, inquiry is still ongoing for this case. So external fire, when it happened, it will have a devastating effect on the life, not to mention the property damage. So roughly just look how does external fire spread. If we look at here, fire can happen, like say in one of the story of that multi-story, and it can spread externally and can cause the fire spread due to combustible cladding through the other story in that multi-story buildings and can cause secondary fire. And if there is a cavity between that cladding, the fire can accelerate and can extend 5 or 10 times original due to this cavity present. A lot of facade cladding materials commonly used. I think everyone know ACP, aluminum composite panel, ACM, they other call it, which sometimes they have combustible material as the insulation core. However, there are also A2 version. When we see A2 is actually a requirement under the European code that mention the product is limited combustible. There are HPL, which is high pressure laminated, which is layering wood and paper fiber, is combustible material, fiber cements, or even stone wool cladding. Do note that stone wool cladding is actually different than the stone wool insulations that we have, but it's kind of like the fiber cement, but it's actually a little bit what you call it, compressed. Where the main ingredient still stone wool. We do under our Rock Wool International Group, we do have this product called Rock Panel. So common use ACP panel, okay, especially that consists combustible core. Some regulation of fire. When they test the ACP panel, they only require the sample to subject to what you call it radiant heat. And this actually is not sufficient enough for that SCP panel to ignite. But the thing is, in real cases, when fire happens, or when they do what you call it full-scale fire test, that SCP panel actually subjected to direct heat. When it's subject to direct heat, aluminium, we have aluminium insulation and aluminium. Aluminium is very, the metal is high conduct. It conducts the foam core in the middle, causing it to melt, causing it to soften, also causing it to ignite cell. So at the same time, because the aluminum skin is very thin, it also starts to melt and exposing more surface area of that PE foam. And due to that, the flame actually starts to spread upward and also downward due to melting of that PE foam. Okay, so that's where you may want to actually start when it comes to designing the external what you call it cladding. What are the material that need to that you want to choose that can have good fire safety? So here is actually I want to go through on country which they have like fire safety requirement for the external wall. Let's look first at Malaysia. Malaysia is actually have made it compulsory for any building which is above the 80 meter high. They have the external wall cladding. They have to undergo, we call it full-scale test. Full-scale test. If you look at here in the picture here, is actually 8 meter high with L shape, 2.6 meter and 1.5 meter width. Okay, what they do is they construct this in a way to simulate, is there like cavity barrier, fixture, fitting, or cladding, and this subject to fire. And you see here there is a, if you look at here at the bottom here, there is the source of fire. Somehow in the cases a fire happened and below, how fast they want to check whether the fire spread upward as well as horizontal. That's why they have the L-shaped kind of wall. And the performance criteria that you look at, it almost the same as country that actually go into the BS 8414 requirements. They look into make sure that certain temperature, the temperature does not exceed certain limits. As well, they look into the mechanical failure, which system does not collapse and does not burn. Okay, for Malaysia, we actually test under BS 8414-1 or BS 8414-2, which is different if you look at here, either mensurate or non-mensurate. In UK, they said that in the building regulation, for any dwelling, institution, residential, the external wall need to be class A1. Class A1 is actually following European code requirement that stated the material is non-combustible, or class A2, which is limited combustible. And below that they do not accept. Okay, they do have certain other compliance where for non-dwelling, they also need to test to the BS 8414, the one that I mentioned in the previous slide, where Malaysia also have need to do the test. Okay, but first and foremost requirement is non-combustible and limited combustible. Similar to Australia, also mentioned that the buildings, okay, have to be the external wall need to be non-combustible, following the Australia test method requirement, almost the same non-combustible to the European code test. And they also what you call alternative solutions. If which is they have to test to AS5113, is similar to if you remember back the full-scale test. Is similar to the BS 8414. Okay, so either your product non-combustible or performance solutions test to full-scale external fire test. Okay, so of all these three, I just want to highlight the requirement you must have for this country. They have to follow that regulation to make sure the building comply with the building code. Rockwool's actually have done comparison using this large scale test that I mentioned, where they have done a comparison using different type of insulation. Actually, you can get this slide afterwards. At the bottom here, there's a link if you want to read about it more. In this test, they actually construct 7 samples, full scale 7 samples, 8 meter high. That consists 2 of the sample is actually using stone wool insulation. 3 is actually using PERAFI polyiso, as well 2 is actually using phenolic foam. And if these 3, you look into reaction to fire performance. Stone wool A1 higher scarification, PERAFI, and phenolic foam combustible material, they only classify as B as well as E. Okay. And at the same time, if you look at here, in this sample, when they construct, you can see that the the sample 3, 4, 3 anti-7, what do they have? 4 anti-7, what do they have is they have this, what you call it, horizontal barrier and vertical barrier. These 2 is actually construct. Let me just show you later to actually prevent the spread of fire. Okay. What you see here, an example, just for example, sample 4, they need 4 horizontal barrier and 3 vertical barrier. So basically, if you look at the slide here, sorry, and before that I want to mention, out of these 7 sample 3, if you highlight here, sample 4 and sample 6 failed the test. Okay, whereas the other 4 passed. But if you look again, even the combustible material that it passed, they need to have horizontal barrier and vertical barrier to pass the test. But for stone wool insulation, even without the horizontal and vertical barrier, they're able to pass the test. So basically, if you look at here, this is how the construction is, around 8 meter high, around 2.4 and 1.5 meter 6 width. This is where the location of the horizontal as well vertical barrier. Okay, roughly is they need this horizontal and vertical barrier, they need stone wool insulation because of the non-combustibility and high melting point of the stone wool insulation. You construct like this. So just actually want to highlight here, PERAFI phenolic foam. If like say you want to use insulation, but having horizontal and vertical barrier, if you have a very large wall, because we don't have very large wall, and you have to construct that horizontal and vertical barrier, if you look at here, at every 2.5 meter distance, and for a large building, it's very, very a lot. So it would be better actually to use a non-combustible insulations. So just a little bit at the end of the test, because the test actually been done for 60 minutes. Picture on how does it look like. The first 2 is the stone wool insulations. You can see that the stone wool insulation is still intact, while the rest of other is already burnt. Okay. All right. I keep mentioning about this, the word combustibility here. So what does it mean? Combustibility is just a measure how easily a substance that actually bursts into flame through fire or through combustion. Different countries will define test method in terms of combustibility. They have their own code, but mostly follow almost the same test method. Okay, in this case, I just want to highlight in European code. European code follow what you call it EN 13501-1. So when you tested the building material or any material to this non-combustibility test, it already stated that your material does not ignite, does not cause the flame to spread, have a very less heat of emissions, have a very less or no at all smoke or toxic gas emission, do not have any character changing, melting, dripping, charring. So what this mean by this character changing? Just for example, if you have any fire melting or dripping, it can cause it to spread to other material inside that particular room. Okay, let's say for example that. So under the EN classifications, it have what you call it A until F. That's how they determine the performance, which is A1, the highest qualifications, A2, limited combustibility, whereas B to F is combustible material. So choose insulation, we have higher classifications when it comes to fire performance. Comparing rock stone wool to other type of insulation, how does we compare for fire, reaction to fire non-combustible? We are A1, whereas you can look at here, generic type of other foam, let's say EPF is around E to F, very combustible, PRR around B to D, okay, or even XPS is around E to F, okay. Another thing that I want to highlight in terms of fire performance is actually what there is another test, what we call it as heat of combustions. It's just measuring in terms of the energy value of fuel that contribute to fire. So how they measure? It measure in what we call it megajoule per kg. So here I want to highlight is gasoline. You know, gasoline is highly flammable. Also can highly what you call very high calorific value that added fuel to the fire. So gasoline is roughly around 46.7 megajoule per kg. And you see here the other foam insulation also very high, almost similar to gasoline. Okay, example here for EPS around 39, PRR is around half of it, usually around 26 and 28 megajoule per kg. Whereas for our stone wool is very low. It does not contribute to any feeling of fire, very little, which is less than 2 megajoule per kg. Another thing that we want to highlight, which is in terms of the melting point. Melting point is where we want to look at where the materials start to change its state from solid to liquid. If you have a material or any insulation, we have very low melting point. So in the way that it can cause the fire to actually to spread from external to internal. So our stone wool have very high melting point of above 1000 degrees C, comparing, let's say, for example, here, foam insulation, which is around 200 degrees C. So that's the reason why in terms of fire resistant requirement for insulation, they will choose stone wool insulations because it's able to prevent the heat transmitting to the opposite sides. Now, we look into evidence base, okay? Stone wool actually does not contribute to fire because, as I mentioned, high melting points, we are very stable at very high temperature, non-combustible to EN 13501-1, does not burn, does have zero flame potential and very little smoke development, as well as does not emit toxic smokes. We have no flame retardants, okay? Because some materials actually they added a layer of flame retardant in a way to prevent the spread of fire, but that material itself is still combustible. So actually the one that provides the fire performance is the stone itself. It gives out the fire resilient property. In terms of what are the solutions that we can apply for external wall using the stone wool insulation? It can be ETICS. It can be, let's say, insulation at the back of the any claddings, okay? It can also be, let's say, here is actually for curtain wall insulations. Okay, so how to choose the right insulation? How do you all prioritize in terms of fire safety? Choose insulation which is demand insulation, which is non-combustible, which has a high melting point, which does not has high significant or smoke emission or even release toxic gases, no melting droplet, no significant toxic product of building. With that, I end my presentations. If you want to know any further, you can go through this our website, roleasia.com. All right.
Awesome. Thank you so much for your presentation, Ms. Azani, and for helping us to, for reminding us of how important fire safety is when it comes to the facades and of course interiors as well in protecting our spaces and our lives. Well, now we are going into our discussion round. In the past 1.5 hours or so, we've heard from our speakers about various materials for consideration for facade, both from the functional as well as the aesthetic perspective. And I'm sure you agree that there's so much knowledge and experience that is being shared here. So now we really want to hear from our audience, hear from our speakers, and we want to get a fruitful and meaningful discussion going. So we have received some questions, but I'm sure there are more. So I would really like to encourage more of you to type your questions into the chat box. But we're going to go ahead and get started, and then we'll just pick up from whatever we see. Okay, so we have about 20 minutes for Q&A, and I will be picking out the more relevant ones, and I will address them to the various speakers. So I think it'll be good to start with our first speaker, Mr. J. So we've got some questions for you. I think people are very curious and very excited to know more about the material that you specialize in. So the question that I have here is from Vonnie, and he was asking, is there any limitation when it comes to the weight of the material, especially when it's applied on a curved shape, flower shape kind of facade? And he was also asking about the installation, whether it is fabricated and segmented, and is it possible for casting on site? Yeah, so maybe you can respond to this first.
All right. Thank you, Vonnie, for the question. I think you've asked three questions. First one is about the weight of the precast panel. Typically, a facade panel weighs about between 1 to 3 tons. It may seem a lot, especially when you compare with some of the aluminum panels. But in Singapore, a lot of construction is all in precast. So they have very heavy element like the precast beams and precast columns, which weighs easily 4 or 5 tons. Sometimes even a modular precast in the whole room is done in a modular precast that can weigh up to 20 to 30 tons. So in that respect, the precast facade panel, given that it's about 2.4, 2.5 wide by about 3 meter high and about 150 mm thick, weighs about 3 tons. It can be made into curve or any circular shape. And I think it will be much nicer to do them in true curves rather than segmented, because I think most architects would prefer when you have a round curve panels like the NTU, they want it to be expressed in the true curve rather than in segmented. So and your last question is, can it be cast on site? Yes, it can, but the quality wouldn't be good because your site you don't have a covered factory, and then you have a lot limited materials, and then also the equipments, not that fancy equipment, but at least you need the crane to hoist the panel. So, and that is easier done and cheaper done in a factory environment.
Thank you. And more questions for you, Jay. We're still staying on you. So from Lawrence, he was asking, how do we maintain the uniformity of the casting result finish according to the control samples design? Yeah.
Good question, Lawrence. This is the most difficult part for us as a precaster, having to manage the color so that it is consistent. Concrete is a natural material. You make it from the raw material, such as a cement, sand, and the granite aggregate, and then water. So it's very difficult to achieve 100% uniformity. The way that we control is by QA, quality control, but it's not that much that it's not a machine-made process. It's all done by hand with a mold that you saw in the slides. So a lot of it has to be done with care and the attention to how we mix it, and then the proportion of the mix and the raw material have to come from the same source. For instance, the quarry for the granite has to be from the same quarry, the cement from the same manufacturer, and so on. But even with that, it's very difficult to maintain 100% consistent. But sometimes architects don't like to be 100% consistent. If they want it that way, they would have chosen to paint it in the first place. So the natural concrete does give a nice touch of the how should I say, the honest expression of the concrete material.
Yeah, I recall you were saying that it is in fact almost like an art piece, right? Because every piece is a bit unique and different. So that's the beauty, and that's why they choose the material.
Right.
Okay, so I think one last question before we have other speakers answer some questions would be, how do we prevent the surface concrete, the surface of the concrete against tropical weather and deterioration within the lifetime of the building, and maybe with some maintenance?
Concrete surfaces, like all other materials, like stone, are susceptible to the weathering, especially in the tropics. But for concrete, the porosity, the density of a concrete is not that much different from that of a stone or, let's say, granite. But normally what we do recommend is to apply a layer of water repellent, which is a chemical that is readily available. A lot of companies sell that. They use it for marble, they use it for tiles, and for granite. You apply on it, and then this chemical will penetrate into the concrete. It's not a film, it's not a coating, but rather it's a penetrative material, and that will stop the water from. It will repel. It will prevent the moisture from getting into the concrete. So if there's no moisture, then it's like less likelihood of dirt carried by the moisture, by the rain into the building. That's how we normally would suggest to the architect or to the client.
Awesome. Thank you, Jay, for helping us understand a bit more. Now I have some questions for Sandrine. So I think one of them you had answered in the chat, in the question and answer box. And another one would be from Veronica. She was saying that usually she specifies the film to go into the bite of the frame. So is this film, Novacell's film, supposed to be removed after installation? Yeah.
Yes, correctly. Our films are supposed to be applied from the fabrication of the IGU to the end of the construction. So this is the main benefit of our film, because it can stay on the glass during all the construction to avoid glass is damaged by co-working around the window during the construction. So yes, it can be removed after.
Okay, so yeah, I think we're clear that this is really meant to be a protective film, right? Okay, and then another question is on cost.
Yes.
How much added cost are we expecting to provide for the glazing budget if we were to use this film?
In terms of cost, I will give an average one. This will be less than €1 per square meter. And for the end users, this can be sold as an option in combination with the IGU, I mean that IGU producers can offer this option and charge their customers for the film they put on the IGUs. This is done right now by our customers.
Yep, understand. Wonderful. Thank you, Sanjin.
You're welcome.
Okay, let's look at our questions let me just have a quick look. Okay, so I have a question for Raphael. And that would be, during the design process, could you share a little bit more about what were some other materials that you were considering, from the very beginning, and how did it become clear along the way that perforated aluminum would be the best choice?
Okay. First of all, basically, it needs to have certain characteristics. Just what I mentioned, it is permeable. It allows transfer of air, cross ventilations, and as well as it's transparent. So basically, the choices of these materials narrow down to two. One is the stretch membrane. Actually, a Ferrari brand of the membrane is the best that we can have. But the problem is installation is very specific on that, and the nature of the government related project will be very fast, and they actually tend to overlook certain things. What happened? One of the projects, the aquatic stadium, using the same materials for different shape. After 2 years, so after the Asian Games done, we see that it gave away, and then a lot of things basically become insightful. So we ask ourselves, I mean, like, are we going to see something like this, let's say 2-3 years down the road? Or we try to compromise a bit on the expectations, and then we can see a better output, a better conformity of the form. Instead of starting to give away, they still keep the shape in pristine conditions, and that's a matter of cleaning work. So yeah, we chose to be knowing that the situation in Jakarta, that the upkeep of the building will not be on that high level. So yeah, we compromise our choices, and then down to the second best that we can afford. And then we actually have the other idea, basically using the synthetic rattans. The synthetic rattans produced by BioLivings here, the local suppliers, that actually it can stand weathers as well, and it can be extend to the interiors. So we bring these materials to the our stakeholders, and then they think that this one is too too complicated. This synthetic rattan. The synthetic rattan has been used for the Indonesian pavilions in one of the biennales, and then it performed well, but maybe because the location of the biennale is in Europe, so there's a lot of challenge. I mean, there are less challenge when it comes to the outdoors exposures compared to us, that will be exposed to the suns and as well as dust. So they think that this will pose a lot of challenge in the long runs. But we love to see, because it's actually local supplied, and then we can control very well on the texture, the sizing, and so on. But too bad that it doesn't have a green light to go on.
Yeah, well, thanks for sharing all these different considerations. Yeah, so interesting. And you were also saying that craftsmanship is one of the main messages for that building. Yeah.
Indeed.
Cool. Okay, thank you so much. And I would now like to ask a question for Azani. So from your presentation, I think it's clear that rock wool is an amazing material, obviously. Okay, so could you actually share some instances where architects or owners might still end up choosing another material, you know, for some other reason. Maybe you could share some examples.
Well, I guess in every insulation, there are pros, there are cons, right? Do you look into, again, you also have to look into project specifics. What are the requirements that you want actually to achieve on that? It can be usually for insulation material. Commonly, we look into thermals, we look into acoustics, we look into fires, or maybe additional requirement mechanicals, or even durability of that particular insulations. And also cost, right? Cost, yeah, also one of the things. Well, they may want to choose. Sometimes is because the building regulation does not specifically stated. Let's say, as I mentioned, for fires, there are minimum requirements, and then that also they may want to choose because of the cost, and they may choose because of the better, let's say, thermal performance than other insulation considerations. They want to choose against pro and cons. Let's say, for example, foams, thermal performance better, but for fire, we are actually non-combustible material. Look into, for me, look into the whole aspect. At the end of the day, try to look into the whole aspect, because you want that insulations to be there for the lifetime of the buildings.
Yeah, that's right. Are there some projects that you can share with us in Malaysia that that have used a significant amount of your material?
Actually, there's various. It does not just again insulations. It can just not less because it's particular for facades. A lot of can be applied to. It can be externally, it can be internally, it can be in terms of fire performance. It can a lot of things. So every different projects that require insulation, there is stronger insulation inside.
Understand. Thank you so much. Thank you. And I would like to draw this discussion round to the close. I didn't see any more questions from the floor. So it would be nice for us to wrap up with one question or one thought from every speaker here. So the question I'd like to ask is, what are your hopes for the facade industry? If you could summarize in one line or two, what would that be? And we'd like to go one round. We can take turns so that we can hear from each of you as a nice way to end our session. Okay, so maybe a few seconds to think.
I can start if you want to.
Oh, wonderful, yes, please.
My hope would be a more sustainable industry. For Novacell contribution, I hope we will be able to launch more sustainable products and fit with the new trend, because users are more and more interested in getting a product with more recycled content or bio content. And I can tell you that Novacell is working hard in that direction. We have already launched products in that perspective. So I hope this will expand soon.
Wonderful. Thank you so much, Sanjin. Sustainability, I remember you did mention that your film, 20% of it comes from like recycled components. So
yes.
Yeah, so remember everyone, please find out more from Sanjin about this. I believe you have more coming up for all of us. Yeah. Thank you. And how
You're
about who would like to go next?
Oh, maybe me. All right. Right. As Sandra mentioned that, due to now current climate change and everything, look into every building materials, look into the sustainable developments. Again, also safety aspect in terms of fire, because a lot of fires can happen currently right now. That also you want to look at. Right. Sure.
Thank you, Asani.
Okay, maybe this is my take. I've been a designer in Singapore, and I've been right now practicing in Jakarta. There are many ways difference and in the term of expectation. Of course, we are basically still exploring whatever possibility that may have provided from the industry, but exercising that idea in a lot of constrained situations like Jakarta, especially in terms of affordability, because we need to do something that can be afforded by the construction here. That I actually need to turn a lot of corners to come up with something that is agreed upon by the stakeholders, especially when it comes to features like sustainability and so on, whereby usually there is a premium that we need to pay for that. And then the stakeholders in countries like Indonesia, whereby they see the building, unlike countries like Singapore, they have a lot to think to consider. So basically, as a designers, we are very, very happy to see more materials that is fantastic and affordable, because the term of affordable here basically very sensible. I come across a lot of friends that basically providing me with information in terms of materials that very fantastic, but at the end of the day, I also have constraints to use in the context of urban like in Jakarta. But when it comes to Bali context, that we can use alternative like bamboo materials and so on, okay, that is plentiful and it's very beautiful. Come back again, our expertise here is in an urban context, and that basically we have a lot of challenge. One notable things, like when it comes to a glass choices of low EV and so on, and it basically they can only come up with selection that is dark colors and so on. But basically we want to afford something more transparent, and that basically there is a premium to pay for that. And so this basically pose constraints to us as a designer here in that situations. So yeah, please come up with something remarkable, beautiful, and affordable. I'll be more than happy to use that.
Wow. Okay, I think everyone is hearing this. So work on it. I mean, that in the end, we are always striving for the best balance, right? Of
Yes.
functionality, affordability, and
For me, basically, when talk to client, I have a very hard time to convince them.
I think we understand. We understand. All right. Thanks so much for sharing your honest opinion, and also like the specific context that you're in Jakarta, in the urban context. So I think we have Jay left. What are your thoughts?
Well, Sarah, I think like everybody else, like Raphael, I want to make my concrete panel affordable. Our client, the main contractor, always looking for the cheapest, and to make it sustainable, like fellow speaker from France, and to make it also beautiful and artisanal, like your work, Sarah. I truly admire how you make glass into it and a work of art. And what you do, you put in a lot of love and passion and attention to an otherwise a very common material, just like concrete. Concrete is so common, just cement, sand, and water and stone. But with a little bit of attention and care, we can make it very beautiful, and we don't have to paint it. You painting in Singapore, you know you have to repaint every 5 years. It's not that sustainable. Anyway, so make it beautiful, cheap, and nice.
Thank you so much. I think
Yeah.
everyone has hit it on a nail.
Happy to hear that.
Sustainable, safe,
Yes, safe.
beautiful,
Yeah.
and affordable.
Yeah.
All right. Okay. It sounds like a tall ask, but I think with everyone's minds and the more we work together, and even beyond borders, like what we're doing today, I think it's nice that at least we don't feel so alone and so like isolated and limited in our choices. That something can be made possible where it seems impossible. Yeah. So thank you so much, everyone, for
Thank you.
for sharing your field of expertise. So to our audience here, we have yes, we have come to our end. We want to wrap up this discussion. And if you still have any questions that you didn't get to ask, maybe too shy, don't worry. You can drop us a note through our social media platforms or on our website. And for today, we've heard from 4 speakers who represent different materials, different perspectives, and open our eyes really to more possibilities and considerations when it comes to creating beautiful yet functional and safe facades. All right, everyone, it is 5:50 p.m. and we have come to the end of the webinar. Thank you so much for joining us today. We hope you have taken away very valuable insights and appreciation for the wealth of experience we have here. Thank you once again to all our speakers, Mr. Jay Fong, Ms. Sandrine Guibert, Mr. Rafael Pasaribu, and Ms. Azani Asmi. Also, thank you to our sponsors, Novacell and Rockwool Asia. Now, there are other exciting webinars coming up, so do look out for it. There will be the next one, the topic on safety in glass and facade application on the 21st of April, 2022. And also don't forget our other BAO events. Information on BAO China, Digital BAO can be found on our website, which is www.glasstechasia.com.sg. Don't forget to follow us on our social media on LinkedIn and Facebook as well. And when you important to us to help us do better again and again. Now we have really come to the end of the webinar. So thank you all. Have a wonderful evening and we hope to see you at the next one.
Thank you.
Thank you very much.
Okay. Bye-bye.
Bye.
Thank you. Goodbye.
Bye.
There's a secret to modern life. A few, actually. Secrets that have been working hard for you for decades. Look closely and you will find them everywhere. Walls, in greenhouses, under trains and inside your wheels. Then the ground. They're blocking sound, insulating, irrigating, purifying, fortifying, so you can focus and play and live and be happier. Getting on with what's most important to you without your surroundings getting in the way. And helping businesses thrive more efficiently while respecting the environment. For the last 80 years, we have been unlocking these secrets inside stone. And we found that by applying our curiosity, passion, and knowledge, we could recreate stone's natural cycle and optimize the use of resources by converting waste into valuable material. Today, Stonewall improves people's work and well-being in all kinds of different ways. It plays a big part in making people's life richer, more productive and more beautiful wherever they might be. But we're sure there's more, and we are absolutely determined to find it, so we can do even more to improve life in societies around the world for decades to come. You might never see these secrets hidden around modern life, and you don't have to. We are proud that you experience their effects every day.